Hello, Julia. I want to play a game. For months you have skipped Mr. Maier's calculus class. Just like your other classmates, you have decided to miss math and instead commit adultery. Every day you leave your boyfriend's room and move on to your next sin, your next man.
In the night I hear him talk, the coldest story ever told. Somewhere far along this road he lost his soul to a woman so heartless. How could you be so heartless? Oh, how could you be so heartless?
You have wiped yourself clean of purity. I hope you have noticed your surroundings. The rules of this game are simple. When my voice stops, you will have 2 minutes to solve your calculus problem before the shark circling you attacks. Live or die. Make your choice.
Too bad about Julia Molo. If only she had solved the problem this way. Let me solve it for you. So, according to the rules of optimization, we have to draw the picture first, which I have done here. It's a right circular cone with a radius, a height, and a hypotenuse of 23, as the problem says. Now, step number 2, write the constraint equation, which here is x squared plus y squared equals 23 squared. And in this case, x is radius and height is y. Now, step number 3, write the objective equation, which is the volume of a right circular cone, 1/3 pi radius squared times height. Step 4, plug the constraint into the objective equation. When we solve for y for the constraint, we get this, root 529 minus x squared. Plug it in to the objective. Step number 5 now. We have to take the derivative of the objective equation, set it equal to 0, and then we'll solve for x. And in this would give, we have to do the product rule. This is the first term, and this is the second term. When you take the derivative, you take the derivative of the first term times just the second term, plus the first term times the derivative of the second term, which is all of this. When you set it equal to 0, and you solve on the calculator, you get x equal to 23 root 6 over 3. Now, you have to take this x and plug it into the constraint to find y. When you do this, you find y is equal to 23 root 3 over 3. And now this gives you the radius and the hypotenuse of the right circular cone that will give you the maximum volume with a hypotenuse of 23. And the last part of the problem is find the maximum volume. So now you enter the x and the y into the volume equation. And when you do this, 1/3 pi r squared times h, you get 24,334 pi times root 3 over 27. That gives you the maximum volume. If Julia Molo had figured that out there on the dock, she would have lived, and she would have played the game correctly.
Oh my god. What is he doing? What is he doing? Help me!
Hello, Alexis. I want to play a game. For months, you have skipped Mr. Maier's calculus class. Instead of learning, you have turned reckless and party on the rooftop every day. You have reached the point of no return with your constant partying. The rules are simple. Your leg is chained to a levee. Once the game starts, the levee will tighten until the door is sealed shut, and this game becomes your tomb. Within your right leg is a calculus problem. You must saw into your leg to retrieve it. You will have 5 minutes to retrieve the problem, find the answer, unlock the chain around your ankle, and escape. Live or die. Make your choice.